Hey guys, welcome to part 3 of our patterns in nature. So today's video is going to be about Meander pattern, which is admittedly the most complicated or the most complex pattern that I've done so far. So today's video is going to be different in that I won't be showing you any code, or I won't be explaining you how the code works and stuff like that, because I've watched the previous two videos and both of them really shocked me. The length of the videos are like 1 hour and 45 minutes and stuff like that. I know you guys' time is precious, so I'm not here to waste any. I'm just going to condense all the logic or how the pattern should work or how it's made into a tiny or concise paint presentation or drawing or whatever. So I've got my drawing tablet today, which is going to be more than helpful. So let's start with our point cloud, and I'm not going to explain how the point cloud is created or the theories behind uniform distribution density and stuff like that, because the previous two videos goes in depth of those topics. So I'm not going to do that today in here. I'm just going to draw a point cloud. So this is going to be a point cloud, and I'm going to distribute it with random points, an n number of points. So within this point cloud we have n number of points randomly distributed with random positions. We call the function each time we have a random set of points with random positions. I'm going to draw a representation of what a meander pattern looks like, and then we can go on to defining logic and how the pattern should work and how the pattern should be generated procedurally, right? So we have a circle, and this circle is going to be our point cloud, and this is going to be our meander pattern. We have to generate a pattern something like this, and patterns like this can be found in nature in coral reefs and something in this inside a cell. I think it's called I've studied it in biology, but I forgot the name of the structure, what it's called inside a cell. So we have to create a pattern something like this. So how do we go about it, right? What are the logics needed for creating a pattern like this? So if you have seen me draw, I started from the lowermost point. I went something like this, like a squiggly line. So this is going to be a starting point. So this point here is going to be our starting point. So how do we define our starting point? What are the characteristics of this point? Well, if you see the Cartesian plane, if you take the Cartesian plane or Cartesian coordinates or x and y graph, this graph is the lowest y point, so the lowest elevation. So we'll take the lowest elevation as either positive or negative. Either positive or negative. The reason for that is certain programs have certain types of Cartesian planes. In Blender, if you go on top it's positive, and if you go on bottom it's negative. But on P5JS it's the opposite way. If you go on top it's negative, and if you come on bottom it's positive. So depending on what programming language or program you're working with, this can really differ, so you have to define it properly. So we have our lowest point or a starting point with the lowest y value. From there, now we have to think about how do we connect the next point. So for that, Dr. Joseph Claghorn in his blog post, he defines something called a parametric scan radius, which is basically means the scan radius or the radius is dependent on the variables of the point cloud. For this instance, it's dependent on the point cloud density. We can take the density of the point cloud or get the average density of the point cloud by taking the average distances between any two random points given in the point cloud. So to calculate that density, we can just say, okay, what's the average distance between this point and this point? We'll get an average distance, and using this average distance as a parameter or an argument, we'll put it inside a function, and that function is going to spit out the scan radius. There is also a more classical or more basic approach to do this. you can just look at the point cloud and say, okay, with this density or with a given density, I can conclude the radius, scan radius can be like 50, 60, something like that. Okay, I'm sorry, I haven't described what a scan radius is used for, so you guys won't get what I'm talking about. So let me just quickly explain to you what a scan radius does and what the reasons of we are using it, right? So I have defined a starting point as the lowest point. So in this set of point cloud, in this point cloud, the lowest point is this, right? So from this lowest point, taking the lowest point as the center, we have to draw a radius of the given value, and I've said the radius depends on either a parametric variable which depends on the point cloud's density, or you can just look at the point cloud and give a random set of values and be like, well, this can work, right? So we can draw a circle with a parametric radius or a given radius or whatever. So this is going to be a center. I know it's a terrible circle, but hang on with me. So this is going to be what we call a scan radius, right? A scan radius basically means from the center of a point we draw a circle with the radius that is either dependent on the point cloud's density, which is the average distance between any two random points in the point cloud, or a predefined radius which somehow you got to know, right? Just by looking at the point cloud, you can kind of infer which is the right radius, right? So the main task for this scan radius is that it should be large enough to accommodate certain points, certain number of points within its radius, and also small enough so that it doesn't cover up the entire point cloud. The reason for that is because the points within the scan radius are considered to be added to the network, like the one we did in the previous video, like the branching video, right? We added to networks and stuff like that. It's similar to that, but in this case the network can change depending on the number of points within the scan radius and depending on the scan radius itself. So for this radius we have 1 2 3 1 2 3 points, right? So the network of this point as a central point will have 4 points inside a network. Excluding this will have 3. So next what we have to do is we have to ask which point within the scan radius has the lowest y value. In our case, the highest y value, because in P5JS it's flipped, positive and negative. We can physically see this point has the lowest y value. So with that point we'll just connect a line. So we connect a point from this. Let me just quickly erase this radius so you guys don't get confused. So this is our first line we have drawn. This is our first line we have drawn from this point to the lowest y value within the given scan radius. So we continue like that. Next we take the same scan radius and draw the scan radius with this point as its center, and then we ask, okay, within the scan radius which is the lowest point? It seems to be this one, so we draw a line and then we keep continuing. Okay, from this point which is the lowest radius, this point, okay, keep continuing like this, like this, like this. And also one thing to mention is that after adding each point we are removing it from the point cloud so it doesn't repeat or come back to itself, right? So if I'm adding this point, I'm going to remove this certain point and this certain point from the point cloud. So when I draw the radius like this, it doesn't come like, okay, I can connect to this point back, right? So it'll keep looping to these 2 points. We have to remove this point from the point cloud, and after this is concerned or connected, we'll remove this as well. So it goes to the next lowest point, not to back to itself or its predecessor. I hope the scan radius thing is clear. So now let's come back to our variables or how we define our scan radius. So as I mentioned earlier, there are 2 ways to do it. One is dependent on the point cloud variable, point cloud density is variable, and another way to do it is simply by just assuming an integer, right? Assuming a value for the radius. What I mean by assume is that when I look at the point cloud, this certain point cloud, I can kind of infer, I can just kind of assume which radius will be good enough to fit certain number of points and not too big or too small to kind of not work, the algorithm for not to work, right? I can just kind of say, okay, maybe 50 is going to work, 60 is going to work, or I can just test it out, like putting random numbers and checking which is the working the best. Personally, I have only done this because the parametric variable function doesn't seem to be working properly because it's spitting out large numbers. Sometimes it spits out like half the time of the canvas itself. So this canvas is, so if the canvas is about 500 by 500, I sometimes get the radius as 250. When that happens, your whole algorithm, the whole pattern is going to feel squashed. It's going to be like this instead of being a proper meander pattern, something like this, right? So you don't want that to happen, so you have to be concerned about the radius. And to be honest, I admit my program or the algorithm isn't the best out there. I've seen another person who followed Joseph Claghorn's post and kind of did his own thing and it was perfect. I don't know what he did there. My concern for his code was it took about like 300 400 something lines, maybe even 600, I don't know. But this program algorithm I wrote is about ended at 250, right? So it's short and concise, but it also has its own downsides. It's not perfect, it has a lot of errors, but still I'm trying to explain it to you guys how to do it based on the original post. So let's come back to the scan radius, right? So the scan radius, the argument the scan radius is dependent on, the parameter is dependent on, is the average distance r. So you're gonna call it as r equals average distance between any two random points. So we take this average distance and multiplied or divided by a factor, and this factor is highly customizable. It's dependent on you and your kind of what works best for you kind of method right here. It's not well defined, we are winging it and it's not perfect, so you can kind of loosely do stuff and call it a day, not to worry about the perfection. So another way to kind of find this scan radius is just, I told you, just iterate over random values and like put 50 60 on the integer and just check which works best for you, and then you can kind of probably get the value out of it. The average distance, so let's come back to the average distance, how to get the average distance between any 2 points in a given point cloud. So if you know anything about average distances and getting the average value, it's basically adding all the set values divided by the number of values. So in terms of average distance, you can, the one way, the classical way, the iterative way, or the for loop way is to kind of loop the entire point cloud distance, right? So I can tell for the first loop I can get the distance between these 2 points, the second loop these 2 points, the third loop these 2 points, these 2 points, these 2 points, these 2 points. Keep going like that and loop it for about like 10,000 20,000 times, which is a lot, yes, and divide that distance by the number of distances, so you'll get the average distance. But you don't have to do that, obviously. There's another function which is called the average distance function. I forgot the formula, so I'll put it on the screen right now while I'm editing, and that's the formula. You guys can use that as well. The problem is this formula hasn't worked best for me. As I mentioned earlier, it gives like huge amounts of values, like half of the height and the width of the canvas, so that's one thing to be concerned about. I'm just going to quickly summarize what we have done so far, and probably from there you can take away and go through the code and all the arrays and stuff like that. I don't want to go through all the arrays and kind of explain to you how the arrays work and why we are pushing values and and stuff like that, sorting arrays. I don't want to go through all that trouble right now. If you guys want to see kind of the fundamentals of how I was working iteratively, you can kind of go back and watch the other two videos. Complete detail I've explained how arrays work, or how I used arrays and stuff like that to use x and y coordinates and stuff like that. So do check that out. This is kind of like the fundamental logic of how to create a meander pattern. So let's go back to the basics or summarize the whole video. So first we need a central point. Our central point we took as the lowest x and y, lowest y coordinate, not x and y. So this is going to be a lowest y coordinate, which is going to be a starting point. So from the starting point we draw a parametric radius or constant radius, whatever, a scan radius basically, with the lowest point, with the current point as the center. So within the scan radius we'll ask how many points are there, right? So we have 3 points. Okay, so from the 3 points take the lowest y value point and connect a line, and after we connect the line, remove the previous point from the point cloud, which is a starting point, and set the connected point as the center to the second scan radius. And this radius is not going to change because we are defining outside of the loop. So we continue like that. Okay, now we ask, okay, within the scan radius, which is the lowest y point? Again we connect, do it again, which is the lowest y point? Do it like that. Okay, which is the lowest y point? Like that, like that, like that, like that. We just keep going, so on, so on, so on. Now there is going to be a circumstance. Okay, I haven't discussed this till now. Thank God I remembered it. So there are going to be circumstances where you'll have something like this. Okay, so you'll have something like this. Even if you draw a good enough draw a radius dependent on average distance, as accurate it can be, you'll end up with situations where there are going to be no points within the scan radius of the given point as the center, right? So for example, you can see here there are no points in the vicinity of the scan radius. So when this happens, what's going to happen is your program is just going to stall, right? You'll see a couple of lines till this point, or if it's at the starting point, you're gonna have a bad day, because there are going to be no lines in the program whatsoever, and the pattern is not even going to be formed. So when this happens, you need to have an alternative approach or an alternative step. You have to tell the program what to do when these things happen, right? So you have to give an if statement. You have to say if the scan radius network, so we'll define an array called a scan radius network, which means it's going to add all the points within the scan radius to that array. So if we say if the scan radius dot network dot length is equal to 0, then do the other stuff. So else, you have to do something else. So what is that else? So if we have the array is empty, or we have, in other words, if we have no points inside the scan radius, we have to do something, and that something is getting the closest point within the entire point cloud, right? So now we don't have any points inside this scan radius, so we'll get all the distances from this point to every point in the point cloud, and we'll just connect it to the closest point. So in this case, this is the closest point. We'll just connect it here, and with this point as the center, we'll draw the same scan radius. So now we have 2 points inside the array. So this if statement is going to trigger and do the following, which is connect this point to the lowest y point within the scan radius. So it's gonna connect to here, and then it's gonna keep looping like that. So the important thing is you have another approach. If your scan radius is empty, you just tell, okay, then connect me to the closest point in the entire point cloud. And if you want to know how to get the distance between every point in the point cloud, you basically run a loop with x1 and y1 as the constant value of this x and y coordinates, right? x2 and y2 as the loop. So if you go through I++ kind of for loop, right, and all these points are within an array, you just use this x and y coordinates, x1, something like this. So this will be the variable x and y coordinates. Just watch the previous video. I've gone in depth to get the distances using the distance formula, which is you'll just iterate through every point in the point cloud, and we'll sort that point from ascending to ascending order. So the first point is always going to be the smallest distance, right? So using that distance and getting that x and y point, you can just connect it like, okay, you're the closest point, we'll connect it here, and we'll do the steps again and again. So thank you guys for watching. I hope you guys understood the core logic of how meander pattern work, or how to create a meander pattern. Now remember, this pattern or the algorithm I've made isn't perfect at all. There are going to be times when you get like an interloop or something like that, I don't know, like crossing each other. So sometimes the pattern can go like this, which is not ideal, but it only happens like very rarely, but it does happen. So if you're going to use this in your game or any procedural system, do keep that in mind. I'll also appreciate it if you guys could help me create a more perfect algorithm. And also about the spiral pattern, I haven't started on that yet, so if you guys have any idea how to create a spiral pattern in point clouds, do let me know in the comment section below. With that being said, I will see you guys in the next video. Take care.